Yes, okay. Good morning. Today I'm going to explain you how to solve a single source shortest path problem using Dijkstras algorithm. Okay, so this is the given graph, the weighted graph. It's a weighted underrated graph. You can observe here I have five vertices and edges are associated with the weights. Okay, first let me to explain how to solve this problem. Okay, the solution. This solution is almost same as the Prim's algorithm. Okay, but in the Prim's algorithm we have constructed the minimum spanning tree, but the Dijkstras algorithm will solve the single source shortest path problem. First let me to explain what is single source shortest path problem. Single source shortest path problem means from a given single source vertex we need to calculate the shortest path to all other remaining vertices. Okay, so for this example source vertex should be given. Okay, so in this example we have considered a as the source vertex. Okay, so to solve this problem first you construct the three columns. The first column is tree vertices, second column is the remaining vertices, and third column is the illustration. It is same as the Prim's algorithm. Okay, so now in Prims also we have constructed these three columns. Okay, so now the source vertex is a. So a, with each and every vertex I have written two informations. So since a is the source vertex, the first information will tell you which vertex is nearest to the tree vertex. Okay, comma, and the second information is about the cost. Okay, so now a is the source vertex. This is the very first vertex in the tree, hence the first information is null, comma, and distance from a to a is 0. Okay, now for the remaining vertices b, c, d, e, calculate the cost. So b is reachable from a? Yes, directly it is reachable from a. Its cost is 3. So b is reachable from a. So first information is a, and distance is 3. And c, we don't have any direct edge from, we don't have an edge from a to c. So hence c null, comma, infinity. Okay, so and d, yes, d can be reachable from a and with the cost 7. E, no, we don't, at present we can't reach e from a, hence e from a we can't reach. Oh, sorry, here I have written a, so let it be null. At present it is null. Okay, oh, this is null, null, comma, infinity. Fine. So now the illustration what it explains, I have taken only one vertex, so that is a. Okay, now in the next step, from the remaining vertices choose the vertex with the less cost, that is b. B of a comma 3, b of a comma 3 is selected and it is inserted into the tree. So let me to insert now b into the tree. Okay, so now I have a to b is inserted, a to b cost is 3, a to b cost is 3. Okay, now you update the cost information and nearest vertex information for the remaining vertices. Remaining vertices are c, d, and e. Okay, so now c is nearest to any tree vertex, so now I have b here. Okay, so initially c was null and infinity. C was null and infinity. Now C is connected to B, so I can reach A from C through B also. So hence C of, I can reach A from C through B. Hence I am going to write here C of B comma, and the cost is 3 plus 4. Okay, now let me explain why it is B, why it is 3 plus 4. C can be reachable, can reach A through B with the cost 4 plus 3 or 3 plus 4. So that is the cost. So now for in the same way you do the calculation for remaining vertices D and E. Can I reach A from D? From A, yes, it's possible through B. So B comma, and its cost will be 3 plus 2. 3 plus 2. Still we can't reach A. Still we can't reach A from E. So hence it is null and infinity only. Okay. So now repeat the same steps. Now from the remaining vertices, select the vertex with the less cost. Now here C cost 7, D cost is 5. Okay, so now I am going to select D now. D of B comma 5. D of B comma 5 is selected. Now insert D into the tree. A, B was already there with the cost 3, and now I am going to insert D also. Now D is inserted and B to D cost is 2. Now the remaining vertices are C and E. Okay. Now update the cost of C and E. So C, from C already we can reach A with the cost 7. Okay, that is through B. Now is it, now we have, what we have to do, is it possible to reach A from C through D also? Verify it. Yes, it is possible. C, you can observe in this graph. Okay, C to D and then D to A. What is its cost? 5 plus 7, 12. But 12 is not lesser than our existing cost 7. Hence I am going to retain the previous values for the C as B comma 7. Okay, what about E now? Can I reach A from E? Yes, possible. E to D, D to A. What is its cost? 7 plus 4, 11. And 11 is lesser than infinity. So I am going to update it as E as E cost is yeah, E is how much now? For 1 minute. Yeah, through D, yes, it's possible. 7 plus 4, 11. But there is one more path is there to reach A through D. One more path is E to D, D to B, and B to A. Okay, this is also through D only. What is the cost of this path? 3 plus 2, 5, 5 plus 4, 9. And ADE path is 11, ABDE path is 9. So which one is minimum? 9. Okay, hence let me to choose the shortest path to reach A from E through which vertex? D. It's how much? 4 plus 4 plus 2 plus 3 is 5. 4 plus 2 plus 3 is 5. Okay, so now from these remaining vertices, choose the smallest one. And C cost is 7 and E cost is 9. So E is selected and it is coming from D through D and cost is 9. Okay, now the remaining vertex, oh sorry, C is minimum, no, sorry, I'm very sorry. C is minimum, C is selected, B comma 7, and the remaining vertex is E, D comma. Okay, so is it possible to update here still the cost of E, because we got one more vertex, nearest vertex in the tree, that is C. Can I reach A through C? We will verify it. Yes, we can reach, but what about the cost? Cost is E to C is 6. 6 plus 4, 10. 10 plus 3, 13. Now at present I am reaching A from E with the cost 9. 4 plus 2, 6. 6 plus 3, 9. But if I follow this path, ECBA path, then the cost will be 13. So 13 is not the best one, so let me to retain the cost 9 only. Okay, 9. Yeah, so now let me to insert C into the tree. A, B, D was already there. Now I inserted C. No, now sorry, you're not observing. Okay, now I am inserting C now. Okay, what is the cost of AB? AB cost is 3, BD cost is 2, and DC cost is 5. Okay, DC cost is 5. Now, okay, this is the partial solution after inserting C. Now the remaining vertex is only one vertex. Select that vertex also and insert into the tree. Okay, now E is also inserted. So A, B, D, C. These vertices are already inserted. Cost are 3, and this is 2, and this is 5, and E is inserted now. Sorry, E is inserted, and E is through D. Okay, so D to E, its cost is how much? D to E cost you have to write. Don't write the total cost. Okay, D to E cost is 4. So now the remaining vertices column is empty. When remaining vertices column becomes empty, you stop the procedure. So because for all the vertices I have calculated the cost. Now how to print the final answer, the cost from A to A. This is the final answer. A to A cost is always 0. Okay, now I want to find the cost from source, because it is a single source shortest path. Now source is always fixed, it's A only. Now I want to print the cost and path from A to B. So you write source first and destination is now B. Okay, what you have to do, go to the tree vertex column where B is selected. Okay, B is selected here. Now see, B is coming from A, so B is coming from A directly. So hence A to B cost is how much? A to B cost is, it is also given in the here only, it's given along with the vertex B, it is 3. Okay, now I want to print the path and cost from A to C. First write source vertex A, and then the destination is C. Now where C is selected? Okay, C is selected here. C is coming from B. C coming from B, and go to B. B is coming from A. Okay, B is coming from A. What is the cost of this path? To know the cost, go to the column, sorry, go to the row where C was selected. C is selected here. What is its cost? 7. Write 7 here. I hope you are following. Okay, now find the path and cost from A to D. Write source A, destination is D. Leave some space here to fill the intermediate vertices. Okay, now go to the row where D is selected. D is selected here. D is coming from B. Okay, D is coming from B, and B is coming from A. B is coming from A. What is its cost? So you observe here, D cost is 5. Okay, that's it. Now I want to find the path and cost from A to E. A and E. A is source, E is destination. Now go to the row where E is selected. E is selected here. E is coming from D. E is coming from D, and D is coming, sorry, you can't see. Okay, E is coming from D, and D is coming from B. D is coming from B, and B is coming from A. What is the cost? Cost is 9. Okay, so now this is the final answer. We got the we have shortest path distance to all other vertices from the vertex A. Okay, this is how you can solve the single source shortest path problem using Dijkstras algorithm. Thank you.